Okay, so in this video, we're going to talk about complex numbers some more. We're going to talk about converting from the standard form to the trigonometric form. And in this video, we're going to be doing this into decimals specifically, so these values are going to be rounded when we get done. I also want to say that this is going to be strictly in radians. And we're going to have a restriction on theta, that theta be between 0 and 2 pi. All right, so we know what standard form is. So you can take a number, a complex number, a plus b I, and you're going to try to convert it to z equals r times cosine theta plus I sine theta. So we need to find the appropriate r and the appropriate theta. Well, how do we find r? Well, r is kind of like the r from polar coordinates, except instead of x's and y's, we have a's and b's. So r is equal to the square root of a squared plus b squared. And then if you remember from before, we have tan theta is equal to y over x. In our cases, this is b over a, which leads us to theta is something like the arctan of b over a. But some quirky things can happen. If you are in the wrong quadrant or you are not in the appropriate domain, you may have to add pi or 2 pi, depending. Maybe. It depends. You have to look and see where your point lies and where the angle actually falls. So I think the best way to tackle this is we're just going to do some examples. All right. Example 1. 6 plus 4i. All right, so we know that r is equal to the square root of 6 squared plus 4 squared. So this turns out to be just the square root of 52. And after typing that into my calculator and rounding it, I got 7.21. We'll be doing 2 decimals for all these problems. So our theta is going to be something like tan inverse of 4 over 6. And we get something like 0.5880. And we need to make sure that this is the right theta before we start rounding here. So what are we going to do? We're going to plot this guy. So let's plot 6 plus 4i really quickly. So we have the real axis here and the imaginary axis here. So 6 plus 4i means 6 in the real direction and then 4i in the imaginary direction. So we're over here. Well, what quadrant is this? This is quadrant 1. This angle is also in quadrant 1. So how would we know that? Well, if you think about your unit circle and the angles here, this is 0. This is pi over 2, but if we have the decimal approximation, 1.57, this is pi, or about 3.14. And down here, 3 pi over 2, or about 4.71. So this definitely falls in this section here, which is quadrant 1. So we have an appropriate angle, that's the right quadrant, and falls between 0 and 2 pi, which was our initial restriction. So we can write out our trigonometric form with these correct values. So we have 7.21 times the cosine of 0.59, that's after I round to 2 decimals, plus I sine 0.59. So this original value here in standard form is now in trigonometric form. And if you are suspicious about this, I encourage you to type this into your calculator and see what happens. It comes out surprisingly accurate. There is a little rounding error, but you'll see that it's basically 6 plus 4i. Just make sure that your calculator is in radian mode. Okay, let's do another one. Let's do -1 plus 6i. So we are going to find our r to begin with. So our r is square root -1 squared plus 6 squared, or square root 37. When we type this into our calculator and then round, we get 6.08. Okay, and now we need to find our theta. So our theta is going to be something like tan inverse of 6 over -1. When we type that into our calculator, we get -1.4056. Now, if we look at this, that is not in this range. It's somewhere down here, probably. But this is definitely not between 0 and 2 pi. So what we need to do is we're going to need to add some value to this. Do we add pi? Do we add 2 pi? Well, let's just look and see what's going to happen here. Let's diagram our initial point. So we are going to be -1 in this direction and then 6 in this direction. So over here. And our angle that was returned is somewhere down here. So we don't need to get all the way back around. We only need to get halfway around. So that means that we're going to add pi. And after you add pi and round, you get 1.74. And so we can convert this to trigonometric form using our r and theta. So we have 6.08 times cosine of 1.74 plus I times sine of 1.74. All right, let's do 2 more. All right, let's do -3 minus 2i. So let's find r. R is the square root of -3 squared plus -2 squared. So this is square root 13, or 3.61 after we've evaluated and rounded. And we need to find our theta, which is something like tan inverse of -2 over -3. All right, so when we evaluate that in our calculator, we get 0.5880. Now we need to plot this to see if this actually agrees. So let's plot it. Real, imaginary. So we have 3 units this way and 2 units this way, right here. So we're in quadrant 3. But if we remember our decimal approximations for pi over 2, pi, and 3 pi over 2, this 0.588 falls here. So we are in the wrong quadrant. We are over here when we need to be over here. So we need to get halfway back around, right? Not all the way back, but halfway back. So we're going to need to add pi to this to put us on the right side. So we're going to be over here instead of over here. So after we add pi and round, we get 3.58 And we can write out our trigonometric form using r and theta. So we have 3.61 times the cosine of 3.73 plus I times the sine of 3.73. Right, so we've taken the standard form and converted it to the trigonometric form. Last one I'm going to do, if you've noticed a pattern, actually falls in quadrant 4. So let's look at 4 minus 2i. 4 minus 2i. So 4 minus 2i, we're going to find our r, just like we did before. So what's our r? Well, our r is going to be the square root of 4 squared plus negative 2 squared, which is square root 20, or 4.47 after we've evaluated it and rounded it. And then we're going to find our theta, which is something like tan inverse of negative 2 over 4. Okay, and when you do that, you get something like negative 0.4636. So let's look at this. Let's diagram this point. 4 minus 2i is going to be something over here. So in quadrant 4. Now where is our angle? Well, our angle is in quadrant 4, but look at this. This is negative. And we had a domain restriction, or rather an angle restriction, that said we had to be between 0 and 2 pi. So our angle actually landed in the 4th quadrant, but it's not in the right range of values for theta. So we need to find an angle that's coterminal, or we're going to add 2 pi to spin it back around to itself. So we're going to add 2 pi. And after we add 2 pi and round, we get about 5.82. And we can write our number in trigonometric form now using this r and this new appropriate theta. So r is 4.47. Then we'll have cosine of theta, which is 5.82. And then add on I sine of theta, which is still 5.82. And there you have it. This number here, this complex number in standard form, is now in trigonometric form. I think that's enough examples. We did one for each quadrant. So hopefully you see what I mean when I say you just need to look where your angle is and where your point actually is, and if your angle falls in the appropriate domain. If we need more examples, I can do a video at a later time.